The puzzle of lost knowledge. Throughout history, humanity has stood in awe of the monuments, inventions, and feats of engineering left behind by ancient civilizations. They carved mountains, raised colossal stones, built cities that withstood earthquakes, and even experimented with electricity, metallurgy, and machines long before textbooks suggest such advancements should have existed. We often assume modern engineering represents the peak of human progress. After all, we have skyscrapers, space stations, and artificial intelligence. But the deeper we look into the ruins of our past, the more we realize something astonishing: our ancestors sometimes accomplished engineering feats that we still struggle to replicate today. How did the Egyptians build the Great Pyramid of Giza with such perfect precision over 4,500 years ago, aligning it with the stars in true north? How did the Incas carve and move massive stones that fit together so tightly? Even a razor blade cannot slip between them without using mortars or modern tools. How did ancient Greeks construct the Antikythera mechanism? A device so advanced it was essentially a mechanical computer, centuries before anything like it should have existed. Even materials puzzle us, like Roman concrete, which grows stronger with age while modern concrete decays within decades, or the iron pillar of Delhi, which resists rust after more than 1,600 years under open skies. These mysteries are not simply about constructions. They speak to something deeper, a lost understanding of natural laws, materials, and technologies that perhaps far exceeded what we give credit for. Were these simply products of brilliant minds pushing the limits of their time? Or do they suggest that ancient civilizations had access to techniques or even knowledge that has since been forgotten? Today, we will journey through some of the most mysterious ancient technology's achievements that defy modern engineering, from colossal stones that modern cranes can't lift, to machines that map the cosmos. Two construction methods that laugh in the face of earthquakes. These relics remind us that history is not a straight path of progress. Sometimes, it feels like humanity knew secrets once and lost them. Let's dive into the greatest engineering riddles of the ancient world. Chapter 1. The Great Pyramid of Giza. Precision beyond comprehension. The Great Pyramid of Giza, built around 2560 BCE for Pharaoh Khufu, is perhaps the most famous monument on Earth. Standing originally at 146.6 meters (481 feet), it held the title of tallest man-made structure for over 3,800 years. Even today, it inspires awe not only for its size, but for the staggering precision with which it was built. The pyramid is aligned almost perfectly with the cardinal directions: north, south, east, and west. Its error margin is less than 0.067 degrees, something nearly impossible without modern instruments. How did the ancient Egyptians, who supposedly lacked compasses, lasers, or GPS, achieve such accuracy? Then there is the construction itself. The pyramid consists of an estimated 2.3 million stone blocks, each weighing between 2.5 and 15 tons. Some of the granite stones inside weigh as much as 80 tons. To move these blocks, they would have required not just manpower, but advanced logistics, ramps, and possibly tools we don't fully understand. Modern cranes today struggle to lift stones of this size, and even if they could, the task of transporting them miles from the quarries, across the Nile, and then stacking them hundreds of feet high, boggles the imagination. The joints between the stones are another marvel. Many blocks fit together so tightly that you cannot slide a piece of paper between them. The casing stones that once covered the pyramid were polished to a mirror-like sheen, reflecting sunlight so brightly that the pyramid would have shone like a jewel in the desert. Even more mysterious is the pyramid's internal structure. Shafts within the pyramid, aligned with specific stars in Orion and Sirius. The Great Pyramid is not just a Timitz, a celestial marker, an astronomical observatory carved in stone. To this day, theories abound. Were massive straight or spiral ramps used? Did the Egyptians invent clever counterweight systems or water-assisted methods? Some fringe theories even suggest lost technologies like sound levitation or machines we can only guess at, while mainstream archaeology insists it was brute force and ingenuity. We must admit the feat is so staggering. Modern engineers with today's machines and budgets would find it difficult, if not impossible, to replicate. The Great Pyramid stands as a symbol of lost knowledge, a reminder that thousands of years ago, humans built something that, even now, leaves us humbled. Chapter 2. Stonehenge. Astronomical and engineering puzzle on the windswept plains of England sits Stonehenge, a circle of massive standing stones that continues to mystify archaeologists, astronomers, and engineers alike. Built around 2500 BCE. This prehistoric monument required moving stones weighing up to 25 tons from as far as 150 miles away. How could ancient Britons, without wheels or advanced transport, haul such colossal stones across rivers, hills, and valleys? Some suggest wooden sledges and log rollers, while others propose that waterways were used as natural highways. But whatever the method, the sheer manpower and coordination required is astonishing. The layout of Stonehenge is equally fascinating. The monument aligned precisely with the summer solstice sunrise and the winter solstice sunset. This suggests it was not just a ceremonial site, but a sophisticated astronomical observatory. Ancient people tracked the movements of the sun and moon, marking time, seasons, and perhaps even eclipses. Modern engineers still debate how the stones were lifted upright and capped with horizontal lintels, creating the iconic trilithon structures. The mortise and joints, used to secure the stones, show remarkable craftsmanship. In effect, Stonehenge was a prehistoric calendar, and constructing it demanded not just engineering knowledge, but also a profound understanding of astronomy. Stonehenge proves that engineering genius was not confined to Egypt or Rome. It flourished, even in seemingly primitive societies. Chapter 3. Roman concrete. Stronger than modern cement, the Roman Empire left behind roads, aqueducts, bridges, and amphitheaters that still stand after 2,000 years. Their secret, Roman concrete, known as opus chem. Unlike modern concrete, which often crumbles after 50 to 100 years, Roman concrete seems to grow stronger with age. Scientists discovered its durability comes from volcanic ash mixed with lime and seawater. This combination created a chemical reaction that produced rare crystals called aluminum turbium. These crystals allow the concrete to heal itself when cracks form, essentially structures like the Colosseum, the Pantheon, and aqueducts testify to this brilliance. The Pantheon's dome, the largest unreinforced concrete dome in the world, still inspires architects today. Ironically, in our quest for quick setting, cheap concrete, modern construction often overlooks sustainability and longevity. Today, engineers are studying Roman concrete to see if we can revive its formula for more durable, eco-friendly infrastructure. In this way, the Romans may have been centuries ahead of us. Chapter 4. The Antikythera mechanism. Ancient Greek computer discovered in a shipwreck off the Greek island of Antikythera. In 1901, this bronze device shocked historians. At first, it looked like a corroded lump of gears, but X-ray imaging revealed something astounding. The Antikythera mechanism was a highly sophisticated astronomical calculator, built in the 2nd century BC. It contained over 30 bronze gears, precisely cut, capable of predicting lunar phases, eclipses, and planetary movements. Essentially, it was a mechanical computer 1,500 years before anything like it appeared again in Europe. Some scholars call it the world's first analog computer. The complexity of the device suggests that ancient Greek engineers had knowledge of gear mechanics far beyond what history books credit. Yet, no other mechanism of its kind has been found from that era. Was it a unique masterpiece, or evidence of a lost technological tradition? Modern engineers attempting to recreate it admit that such precision would be difficult without advanced lathes and tools. The Antikythera mechanism reminds us that innovation is not always linear. Extraordinary knowledge appears, then vanishes into history. Chapter 5. Machu Picchu. An Inca stonework, earthquake-proof, without mortars high. In the Andes lies Machu Picchu, the fabled lost city of the Incas. While its beauty is breathtaking, its engineering is equally jaw-dropping. The Incas built walls of stone so perfectly cut and fitted that not even a blade of grass fits between them yet. They used no mortar. This technique, called ashlar masonry, gave the structures incredible earthquake resistance. Instead of collapsing during seismic activity, the stones danced, shaking and settling back into place. Modern earthquake engineers marvel at this technique, which in many ways outperforms reinforced concrete. The mystery deepens when we consider how the Incas shaped and transported stones weighing up to 100 tons without iron tools, wheels, or draft animals. Some theories suggest they used bronze chisels, sand abrasion, and sheer manpower. Yet the level of precision rivals modern laser cutting. Machu Picchu is not alone across the Andes. From Cusco to Sacsayhuaman, colossal stone walls testify to this lost craft. While we use rebar and cement, the Incas simply used geometry, physics, and flawless craftsmanship to achieve something we still struggle to replicate. Chapter 6: Baalbeks, Trilithon stones. Impossible weight in Lebanon. Lies Baalbek, an ancient temple complex dedicated to Jupiter. But what truly astonishes visitors are the Trilithon stones, 3 massive blocks each weighing around 800 tons, with one unfinished stone nearby weighing over 1,000 tons, known as the Stone of the Pregnant Woman. To put this in perspective, modern cranes can barely lift such weights. The ancient builders not only quarried these stones but transported and positioned them with incredible precision. How? No one knows for certain. Some argue wooden rollers and ropes, but the logistics remain baffling. Even if such methods were possible, aligning stones of this size into a wall with millimeter precision seems nearly impossible. These megaliths spark theories ranging from lost ancient machines to extraterrestrial help. While mainstream archaeology insists it was brute force and ingenuity, the Trilithon remains a mystery that modern engineering cannot easily solve. Chapter 7: The Baghdad Battery. Ancient electricity. In 1938, archaeologists uncovered a curious artifact near Baghdad, a clay jar with a copper cylinder and an iron rod. When reconstructed, it resembles a simple galvanic, primitive battery. Could the ancients have harnessed electricity 2,000 years ago? Some experiments suggest the Baghdad battery could produce a small electric charge, enough for electroplating gold or delivering a mild shock. Skeptics argue it may have been a simple storage jar, not a battery. But the fact remains, the design eerily resembles later electrical devices. If it truly functioned as a battery, it would push back the history of electricity by millennia. Chapter 8: The Iron Pillar of Delhi. Rust-free metal. Standing in Delhi, India, is a 7-meter-high iron pillar weighing over 6 tons, erected around 400 CE. What's remarkable is not its size, but its resistance to rust. For over 1,600 years, it has stood in rain and humidity without corroding significantly. Modern metallurgists discovered the secret lies in high phosphorus content and a protective oxide layer that prevents rusting. Yet, reproducing this on a large scale remains challenging even today. This artifact demonstrates ancient India's advanced understanding of metallurgy, a field we often assume only flourished in modern times. Chapter 9: Chinese Seismograph. Detecting quakes before modern tech. In 132 CE, Chinese inventor Zheng Heng created the first known seismograph. It was a bronze vessel with dragon heads holding balls. When an earthquake occurred, the mechanism released a ball into the mouth of a toad, indicating the direction of the tremor. Amazingly, it worked even, detecting distant quakes, invisible to the naked eye. Western civilization did not develop similar devices until the 19th century. This seismograph shows how ancient China led the world in science and engineering, centuries ahead of Europe. Conclusion: lessons from lost technologies. As we've seen, the ancient world was not a time of ignorance and simplicity. It was an age of profound ingenuity, experimentation, and mastery of materials and physics that we are only beginning to understand. From the impossible precision of the Great Pyramid to the self-healing properties of Roman concrete, from the astronomical computer of Greece to the earthquake-proof stonework of the Incas, each of these feats challenges our assumptions about history. What's striking is not just the achievements themselves, but the fact that so much of this knowledge was lost. The fall of empires, the passage of time, and the rewriting of history often meant that brilliant discoveries vanished for centuries. Modern civilization had to rediscover what the ancients already knew, or, in some cases, we are still trying to catch up. These mysteries remind us of humility. Technology does not always march forward in a straight line. It rises, falls, and sometimes disappears. Perhaps we are not as advanced as we think, but simply the latest link in a long chain of human innovation. So, the next time you marvel at a skyscraper or a smartphone, remember, thousands of years ago, humans stood beneath the stars, moved mountains, and built wonders that defy even today's machines. The ancients left us riddles in stone, metal, and forgotten devices, reminders. Then Lawless, once lost, can be as mysterious as the cosmos itself.